Remember that all design codes, American, Canadian, Australian, British, Euro codes, they are all based on testing for sheetings which were from 50 to 80 millimeter deep deckings. So anything after 80 millimeter, 100 or 120 or 150, we don't have any formula for shear studs. And manufacturers normally they will provide that formula, which means that more and more research is required to bring these things in different design codes. We cannot simply rely on manufacturers' guidelines. That is just, they will just give you empirical value. They will carry out testing and then give you empirical value. So a lot of testing is required in my view to bring them into design codes. And if you work out shear stud connection for the strength of shear stud using this decking, using Eurocode formula, you will get wrong results. That will not be realistic. So this is a knowledge gap that needs to be filled.
Okay, the next question may be, what are the key advantages and limitations of each composite floor types in terms of span, depth, speed, and structural behavior?
Excellent. This is very interesting. We have different flooring system. For example, if we have timber flooring system on top of steel column, then it is spanning capability is from 2.5 to 4 meters. The depth is 150 to 300, and construction time is medium, I would say. Degree of lateral restraint is very poor. It means that it does not provide any diaphragm action. Diaphragm action means that it does not contribute to lateral load resisting system. And we use it in domestic areas. But nowadays with this CLT, cross-laminated timber, we use sometimes in multi-story buildings as well, as you saw earlier. This information is taken from Manual of Design of Steel Building to Eurocode 3 from iStructy, Institution of Structural Engineers. This was published in 2010. So some information can be a little bit dated as well. So I will tell you which one it is. In situ concrete means reinforced concrete. The spanning capability is as much as 6 meters in this case. And the depth is 150 to 250, medium. On the other hand, here degree of lateral restraint is quite a lot. It's very good, and diaphragm action is very good as well, and we can use it in any type of structures. Precast construction, this information is dated. This is in this book, 3 to 6 meters, but nowadays we have precast hollow core slabs which can span up to 18 meter, and I will show you some of load span tables as well. And nowadays typical depth can go up to maybe 450 millimeter as well, and we use it in a system where we have column free space required and we have beam free space. In some of the classrooms at University of East London, we have this precast hollow core slab being used. By the way, University of East London is entirely made up of steel structure, steel and concrete composites. And construction time here is fast because we don't need any form work. Degree of lateral restraint is not that much in this system, and we can use it for pretty much everything, all types of buildings. Profile decking slabs, shallow decks, they can range from 2.5 to 3.6. Deep decks, they can range from 4.6 to 5 meters. But nowadays, they can span up to 6 meters as well. And nowadays, we have slim deck slabs as well, which can span up to maybe 8 or 9 meters as well. 110 to 150 and 200 plus. Construction time is fast, and degree of lateral restraint is very good, and diaphragm action is very good as well. We use it in almost all categories, but the vibrations must be checked. Now I will move to what is spanning capability of different sheetings, and this is very interesting. 50 millimeter spanning capability is about 2.5. So if you have 2.5 slab span, remember that this is span of slab. Then use this. 60 millimeter about 3 meters. 80 millimeter is about 4 meters. And 146 MD span, multi-decking span, it can span up to 5 to 6 meters. So this is very deep sheeting. Remember that all design codes, American, Canadian, Australian, British, Euro codes, they are all based on testing for sheetings which were from 50 to 80 millimeter deep deckings. So anything after 80 millimeter, 100 or 120 or 150, we don't have any formula for shear studs. And manufacturers normally they will provide that formula, which means that more and more research is required to bring these things in different design codes. We cannot simply rely on manufacturers' guidelines. That is just, they will just give you empirical value. They will carry out testing and then give you empirical value. So a lot of testing is required, in my view, to bring them into design codes. And if you work out shear stud connection for the strength of shear stud using this decking, using Eurocode formula, you will get wrong results. That will not be realistic. So this is a knowledge gap that needs to be filled. And ASB is a slim floor deck where you can see that the decking is inside the bottom flange of the beam. It is 6 meter plus. What is a symmetric slim deck beam? Here the decking, it rests on bottom flange, and then we pour concrete and then we do everything else. The purpose of this type of system is to reduce the depth of the section. Here the depth is 255 to 400 millimeter overall, and it can span up to 6.5 for unpropped construction and up to as much as 9 meter for propped construction. Now what is ASB? I will play this video here.
Symmetric is a proprietary shallow floor system. It is a composite system comprising of an asymmetric slim floor beam, or ASB section, contained within the depth of the slab. The ASB supports deep deck profiled metal decking. Slim deck reduces the construction depth since the beams are contained within the depth of the floor slab. This reduces the overall depth of the floor structure and gives 60-minute inherent fire protection. Spans of up to 9 meters are possible, and service ducts of up to 160 millimeters diameter can be accommodated within the trough of the decking.
Now, I would invite you to have any comment, and my question to you is that which type of composite beam would you not consider as laterally restrained? Please type in your answers in comments.
Okay, one question, like, is the spanning not dependent on thickness and profile?
It depends on the thickness of the deck. It depends on the profile type as well. So as I mentioned, that 50 millimeter will not have much spanning capability, only 2.5. On the other hand, 146 millimeter will have a lot of, in my view, load span table, they would give a lot of depth of concrete. I would not use a lot of deep concrete. So for example, for 60 millimeter deck, I would use the minimum one, which is 130 millimeter overall depth. And if you increase depth, obviously in load span tables, you will have a lot of depth as well, but that increases a lot of dead load on the structure. Unless if you have any concern about vibrations and stuff, don't use very deep decking. Use deep decking, but don't use depth of concrete, which is quite a lot. It is dependent on thickness, yes. So thickness, most of these sheetings, they start with 0.91 millimeter, 1.2 millimeter. So as you increase thickness of the sheeting, the spanning capability increases as well. Yes, I was giving this rough idea. I will give detailed load span table little later.
Many times it's also used in retrofitting projects.
Retrofitting as well. All right, excellent.
Steel beams without shear connector will be laterally unrestrained. Yeah, so these ratios are for the conventional RCC structures, whatever
Okay, all
details
right.
which are. So
Okay.
whether those span depth ratio given for the conventional structure, is it applicable? Same is applicable to the precast members.
No, not at all. No, they're different.